UMLs are diagrams that are used to design objects. They're in this format. So what happens is we put the class name at the top, then we put all the private elements of the class, specifically normally the instance variables. Sometimes there's methods too, but for us, just instance variables. And then we put all the public elements, which are going to be our methods, in the bottom. So yesterday we had looked at a Sushi Go card game, and we had this information and we created this object. So that would mean that we're going to put sushi at the top. We're going to put these private instance variables, the name and the num, in the next section down, the private section, and then we're going to put each of the method signatures into the other section. So it'll look like this. You can see that I didn't put private in before these, and I didn't put public in before these, and that's because it's implied by its position in the diagram. So we know that these ones are all going to have public in front of them, and these ones are all going to have private in front of them. So we also made a stack, and the stack would work out like this. We have our two private elements right here. We have the stack name, and then we have each of our methods in the bottom section, the public section. As well, we made a sushi stack runner. And as soon as we get up to this stage, I think you can see why UMLs become a bit more useful, because this diagram summarizes all three pieces of code that we needed to actually run things. We needed the sushi stack runner to call the sushi stack, and the sushi stack called the sushi. And we can see that all of the methods and all of the things together in this diagram that allow us to understand what the code's going to do. Another thing that's handy is that we need to know which objects are calling other objects, which classes call others. And you can see here that sushi stack runner is calling sushi stack, and sushi stack is calling sushi. And so we indicate the dependence between the stacks using an arrow. And the way I think of them is you're like, hey, where is sushi stack? Oh, it's over there. Where is sushi? Oh, it's over there. And the arrows work in that way. They're kind of pointing to where things are. Now, showing dependence is maybe not as exciting when you only have 3 diagrams because it's pretty obvious where things are. But if you have more objects, say like you're running a big social media firm like Facebook or something, they might have 200 objects, and understanding the dependence between them gets very complicated and is very difficult. So another thing we coded yesterday was we coded the printer jobs. And so if we were going to make a UML for this, we'd put printer job at the top, we'd put our 2 private instance variables here, and then we put all of our methods in the bottom. So there we go, and then our methods will come at the bottom. All right. We also made a printer job queue, and then we made a class to run the printer job queue. So when we put all 3 of them together, they're going to look like this. We're going to have a main activity. It looks like this was done in Android, and the main activity has a queue, and the queue is over here, and then we have a printer job. So the queue is going to be a queue of printer jobs. So it would look like this. So something that's useful to go over at this stage, which is really easy to see in these UMLs, is it's really easy to classify your methods into the various method types. So first of all, we have declaration, and declaration is all about setting aside RAM. Constructing is all about setting up our dynamic memory, so we're ready to use it. It uses the keyword new. Mutators are all about changing your dynamic memory. That uses the keyword set. Facilitators are anything that doesn't come up in the previous stuff, equals and compare to. And accessors are about checking to see what is in dynamic memory so we know what the heck's being stored. There gets 2 strings, and I don't think I've said this before, there also is. So is it visible? Is it full? Is it empty? Those sorts of things. The pictures I use go kind of like this. So I think of declaration as being the mummy and the daddy fall in love. And then along comes a bouncing new baby object. And the bouncing new baby object then throughout its life might get new clothing, it might grow and mutate. The bouncing new baby object will learn to speak and will give information about itself, things it knows, that sort of thing. And the bouncing baby object will also acquire new skills like playing beach volleyball or doing math or something. And so they're really easy to classify when you can see the object method names all together like this. You can see our bouncing baby queue and our bouncing printer job, which has 2 options for the bouncing baby. We've got the various mutators, you've got the various accessors throughout there. Okay, good luck with making UMLs.